Okay, let's look at the 24-hour parenteral intake problems. Now, that's just 24 hours. In 24 hours, how much does your patient receive by IV? That's all parenteral means, by way of IV. So, the patient is often receiving a number of different IV fluids at the same time. Now, let's look first at the difference between primary fluids and secondary fluids. Primary fluids normally come in liter bags. These are the bigger bags. The doctor comes in, he orders the fluid, and he orders the flow rate. And those fluids then run hour after hour after hour after hour. And as the bag empties, a new bag is hung, and they continue to run hour after hour until either the patient goes home or the doctor comes in and says, okay, he doesn't need IV fluids anymore. He's taking nourishment well by mouth. He doesn't need the IV fluids. And he stops the IV fluids. But otherwise, they continue running forever. Then the secondary fluids, so that's primary fluids. The secondary fluids are things like your antibiotics, your riders, those kinds of things. These are relatively small bags. They're usually 50, 100, or 250 milliliter bags. And they run periodically for a brief period of time, and then they don't run again until the next time they're ordered. So let's say you have an antibiotic in a 50 milliliter bag, and it's ordered to run every 8 hours. So it runs at 6 o'clock in the morning, and it runs, let's say, for 30 minutes. And then it doesn't run again at all until 2 o'clock that afternoon, 8 hours after the last time it ran, and it runs for 30 minutes, and then it doesn't run again until 10 o'clock that night when it runs again for 30 minutes only. That's all the more that happens with your piggybacks or your riders. Relatively brief amount of time, periodically, and otherwise they're not running. Now here we have a problem where you have, let's look at an example here. Okay, one of the things that I probably should mention before we get into the specific problem. We talked about the pump, and the pump is very smart. It only speaks one language now, milliliters per hour. But the thing that the pump is not very smart about is it can only run one fluid at a time. So any time that the piggyback starts running, the primary stops. And then the minute that that piggyback is done running, the primary starts up again, and it starts up automatically the minute that the secondary is done running. So something's going to be running 24 hours a day. It just isn't always going to be the primary. So let's look at something here. The patient has D5W, and it is ordered at 100 milliliters an hour. They have antibiotic A, and it's 2 grams in 250 milliliters, and it's every 12 hours. And it is infused over 90 minutes. So each dose will take 90 minutes to go in. Antibiotic B is 1.5 grams in 100 milliliters, and this is 3 times a day, and each dose is infused over 1 hour. Then there's antibiotic C. Actually, we're going to call this a potassium rider. So this is potassium. And there's 50 milliliters, which is only going to run in once, but it's going to take 2 hours to run in. Okay? So that's your basic information for the problem. Now, that's a lot of information. You got all this data, and you say, what the heck do I do with this? Well, the easiest way to do it is simply to put it into columns. So we're going to make a column for D5. And we know that the D5 runs at 100 milliliters per hour. And right now, that's all we care about. We're going to stop there. Let's look at the secondary fluids. We've got A, and we know we don't care about how much medicine's in there, only the volume, because we're looking for a total volume intake. So A has 250 milliliters per dose. And how many doses a day? Every 12 hours. So 2 doses a day is 500 milliliters. So in one day, that patient gets 500 milliliters of antibiotic A. Now let's look at antibiotic B. And antibiotic B is 100 milliliters per dose, 3 doses a day, or 300 milliliters. And then your potassium, you can't forget the potassium, is 50 milliliters. It runs only once a day, so that's 50 milliliters. So in a 24-hour period, that's how much of each of those runs. Now, let's come back to the D5. This is the only one involving time. These don't involve time, just how much per dose, how many doses. On this one, we need to know how much time will the D5 actually be running. So what we need to do now is figure out how much time each of these is running, because while they're running, this stops. So let's start with the potassium. We said it's going to take it 2 hours. So we're going to take off 2 hours here. Here we have 3 doses a day, each infusing over 1 hour. So 3 hours a day, that's running. And the antibiotic A, every 12 hours, so twice a day, it's infusing for 90 minutes. An hour and a half, twice a day, is another 3 hours. So this is infusing for 24 hours minus 3, 6, 8 hours, or 16 hours. So this is 1,600 milliliters, and you simply add these across for your total in 24 hours. 16, 21, 2450. 2,450 milliliters of IV fluids in 24 hours. Now, this looks complicated. It really isn't. You just do it step by step like I just did. I'm only going to do the one example here because you have an example in your lab manual that goes through it step by step like I just did. And if you will follow that example in doing these problems as you're practicing, you won't have any problem with them.